This video is going to cover the topic of unit rates with complex fractions. Be sure the date and topic are at the top of your page. Our essential question will be, how do we calculate unit rates when working with complex fractions? And we've been working with unit rates as we've worked to investigate proportional relationships. We know that we need to calculate the unit rate when we want to create an equation, but so far we have worked with mostly friendly numbers. However, in the real world, numbers can be complex. So let's take a look at some examples with fractions. And regardless of the fact that this time we're dealing with fractions, a unit rate is still a ratio of two different quantities where one of the values must be 1. Our first example tells us that to mow 1/4 of a lawn, you need half a gallon of gas, and we're trying to figure out how much we need per lawn. So for one lawn. We know this is a unit rate question because we're looking at this one lawn. And I'm going to use this time to solve this by looking at a table. And I know that in my table I'm comparing the amount of gas that I need for the part of the lawn that is getting taken care of. So I'm just going to use some friendly skip counting to fill this in. I know I'm trying to make it to one whole lawn, so I'm just going to count by fourths down here until I get to 4/4 or one whole lawn. And then I would kind of keep that same consistent pattern. I would count by halves moving up this way. So it would be 2 halves, 3 halves, and then, whoops, that should say 3 halves, and then 4 halves, so that I know that one lawn requires 4 halves of a gallon of gas, but that's just 2, right? So it'd be 2 gallons per lawn, right? And the table is nice and friendly in this situation to solve this. In our next example, it says that it took Mark 3/4 of an hour to read 1/8 of his book, and we want to know how long it takes him to read one book. So of course that means we're looking for his unit rate, right? The speed per book. And similar to a table, I'm actually going to set up a double number line to solve this one. So my double number line has been set up with hours and amount of the book that he has read, and we know that in 3/4 of an hour he reads 1/8 of the book. So I'm just going to grow my double number line, and I'm actually just going to grow by eighths because I know that that will eventually get me to his whole book. So I'm going to go take a minute and fill that in. You can do the same. And every time I add an eighth to the amount of book that he read, all the way up to getting to that one whole book, my 8/8 done, I need to count by 3/4 for my hours. So the second line here, I'm going to say, well, that's 3/4 plus another 3, that's 6/4. And I would add another 3/4 and another 3/4 and so on, so that I know each kind of relationship here that matches up with a part of the book that he has read, right? And by the end of it, I find out that it would be 24/4 of an hour it would take him to read his one book. But of course, 24/4, right, is the same as 6. So he is reading his book in 6 hours. But we also could have done this with equivalent ratios. I'm going to turn my page and show that as well. Hopefully we remember that we can also set up equivalent ratios when we want to find a unit rate. And so I know that it's 3/4 of an hour for every 1/8 of his book, and I'm looking for one book's length, right? So I'm making that equivalent ratio. And then I know, oh, well, 1/8 times 8 will get me his whole book. And so I would multiply my 3/4 times 8. And let me just remind myself how to do that. 3/4. And I would have 3/4 times 8 over 1. And 3 times 8 is 24. 4 times 1 is 4. Oh, I still get 24/4, which is still 6 hours, right? Same solution, different strategy. And speaking of strategies, there's yet another way that you might approach this. And it might be useful when we work with even less friendly numbers, with even more complex numbers. We are looking for hours per book. So one thing we can do is take our hours and divide it by the amount of book that he read, right? So we can take, 3/4 of an hour and divide it by his 1/8 of his book that he's read. Now this, of course, makes us have to remember how to divide fractions, but we would keep our 3/4 the same, and we would multiply by the reciprocal, right? Which, of course, is still 24/4 or 6, right? Same answer, 3 different ways. And this will be useful when the numbers don't lend themselves to tables or to this easy scaling like we saw in the example above. So this is an example where it's not as friendly a set of numbers. So 3/5 of the cafeteria can be cleaned with 1/3 of a bottle of solution. We want to know how much is needed to clean the entire cafeteria. That's kind of a hidden way of saying one whole cafeteria or the unit rate. So we need to find the amount of solution per cafeteria. And that means, of course, that we can take the amount of solution and divide it by the amount of the cafeteria that has been cleaned, right? So we know that the solution is 1/3, and we want to divide it by the amount of the cafeteria that can be cleaned, right? This is not an example where it would be nice to kind of skip count to get to one whole, right? 3/5 does not skip easily into one whole. So I think this last option of just straight division might be our best choice here. And when we do that, of course, right, we keep that 1/3 the same, we multiply by the reciprocal, and we get 5/9, which means that it takes 5/9 of the bottle per cafeteria cleaning, right? So if we want to do the whole thing, it would take 5/9 of the bottle per entire cleaning. And I think this might be a good reminder, right, to divide those fractions, what we need to do for that, but also to remember that we can use that as an option. We can certainly use tables, we can certainly use double number lines and other scaling ideas, but if you get these complex fractions, sometimes it's just best to divide what it is that you want per item. And lastly, we need to be aware that sometimes our complex fractions also involve mixed numbers, like this one. It costs $11 for 1 5/6 pounds of roast beef, and we want to find the price per pound. This one's not really a really friendly one to use a table or to scale, right, to make 1 5/6 easily go into one whole pound. So I'm going to do that division strategy. And since we're looking for the price per pound, that means I'm going to take the price and divide it by the number of pounds that we know we have, right? So what I essentially am doing is 11 divided by 1 5/6. So a quick reminder here on that. When we're doing a whole number, we want to make sure it looks like a fraction. So we're going to turn that into 11/1. And then we're dividing it by this mixed number. So remember that 6 times 1 is 6, plus 5 is 11. And the denominator stays the same. And finally, we have to remember that we need to keep our first fraction the same, but multiply by the reciprocal. And when we do all that, we get 66/11, which of course is the same as 6. Which means that if it costs $11 for 1 5/6 pounds of roast beef, it is the same as saying that it is $6 per pound. And as we work with ratios and unit rates, be aware that sometimes we will see complex fractions in kind of in our way, right, as we're trying to solve something. So that's why the essential question for this video is how do we find the unit rate with complex fractions? And we've seen that there are certainly various ways that we can use to solve these, like tables, double number lines, equivalent ratios, or just brushing up on dividing our fractions and solving it that way. So be sure to bring your notes and any questions you have to class.